So on the board here today, we have laws of indices for same base situations. So I'm just going to roll over all of them. But before I go into that, I want you to understand that the concept of indices is the whole concept of indices is derived from the repetition of multiplication, just in the same way multiplication is the repetition of addition. So, so when you face a problem with when numbers have powers, I want you to think of it in a very simple way. So what I mean by repetition of multiplication. So think of indices like this. I give you a number, say 3 power 2. So I want you to think of it like this. It is just the same thing as saying how many times does 3 repeat itself in terms of multiplication. So that's 2 times. So that's going to be 3 times 3, 2 times, repeating itself 2 times. And that's what it is. It equals to 9. So that's just the, should I say, prerequisite for you to understand the laws of indices. So having understood this concept, let's continue. So the first one is called the multiplication law, and it goes like this. Um, you have you have numbers of the same base but with different powers. The answer, if you are going to multiply those numbers, your answer is going to be that base raised to the power of the summation of those two numbers. I think I'm speaking too much. Let me just show you what I mean. Let's change this to figures so they can be easily worked with. Let's use 2 power 2 times 2 power 3. And this law is telling you that this is equals to 2 power 5. To know if this is actually true, here's what you're going to do. So you write this, I told you this means this times how many times you repeat it, and continue how many times you repeat this, 3 times. So this is 1, 2, 3, 4, 5, and that is equal to this raised to the power 5, just the same way. 2 times 2 times 2, 3 times 2, 4 times 2, 5. And that's what multiplication rule means essentially. So this is what this whole thing means. So quickly we go to the second one, that's division rule. The same way. So let's say we use 2 again. To, I think I should just make space. 2 power, let's say 4, divided by 2 power 2 is equal to, the law is telling us we are going to have 2 power 2 because you do 4 minus 2. The same way, you just do it 2 times 2 times 2 times 2 all over 2 times 2 is equals to 2 times 2. To know if we are correct, you cancel out, cancel out. This is what you're left with, and it's the same with this. So the law is correct. We've gotten the second one, that's division rule. We go to the third one. The third one, that when you raise a number to the power 0, you get 1 as your answer. It's simple to cram that, so if you can cram it, cram it. But if you really want to understand why, so I'm going to give you another first principle explanation, really simple. So let's take, for instance, for a moment, just think of it this way. If you do 2 minus 2, you get 0. Okay, so using that same concept, if you do 2 power 2 minus 2 divided by 2 power 2, this is indices, you're going to have something like this. 2 raised to the power 0. Reason being because when you are doing division, it's actually multiplication of the power. Sorry, it's actually subtraction of the powers. So when you subtract these powers and leaving the base the same, this is what you're going to get when you do this kind of thing. And we are telling you that this is equals to 1. Here's why. Take this into first principle. This means 2 times 2 over 2 times 2. So everything cancels out, leaving you with 1 over 1, which is equals to 1. So that's it. That's it for this one. We go to the fourth one. So for the fourth one, the same way. So I'm going to use numbers again. Let's use 2 again. Use 2 raised to the power, let's say 3 divided by 2 raised to the power 5. It's going to give you something like this, 2 raised to the power minus 2. And to know why this gives you this, 1 over 2 raised to the power 2, according to the law, the fourth law, we go back to first principle as usual. So let's take this 2 times 2 times 2 all over 2 times 2 times 2 times 2. When we cancel these things out, 1, 2, 3, 4, 5. When we cancel these things out, we'll be left with 1 up here over 2 times 2, which is essentially 2 power 2 because repeated 2 times. So that's why we have, see, very consistent. That's how the fourth one came about. We go to the fifth one, just going to be rounding everything up quickly. To the fifth one, if you have 2 raised to the power 3, all raised to the power 2, and that would be, say, 2 raised to the power 3 times 2, which is equals to 3 raised to the power 2 raised to the power 6. Because that's just going to be really straightforward. You have 2 times 2 times 2. So you are supposed to repeat this whole thing, treat it as one number and repeat it 2 times. So you're going to have, okay, let's put our multiplication sign, times 2 times 2 times 2. So you just roll over everything and then you see you have 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. And that's this. So that's the explanation of the fifth one. For the sixth and final one, so when you have 2 raised to the power, let's say a fraction 2 over 3, we are saying it's going to be equal to the third root of that 2 raised to the power 2. Okay, before I explain this, I'm just going to just explain the concept of square and square roots. So ignore this for a moment. Think about this instead. So you have 2 raised to the power 2. Now this is a typical representation of indices. So this means 2 squared. You understand that the reciprocal of a number, let's say just this, 2 itself. 2 means 2 over 1. So the reciprocal of 2 would be 1 over 2. If I raise a number, the same 2, to the reciprocal of this 2, this would be square. So this would be square root because um, math has it that the reciprocal of square is square root. Now this, to represent this, I'd be having something like square root of 2 raised to the power 1. But because 2 raised to the power 1 is equals to 1, there is no point writing that. So in the same vein, we use this. We put that into this. So the down one, just always memorize it. The down one goes into this. So this is the third root of 2 raised to the power 2, and that is the explanation of the third one, of the sixth one. So I want to say thank you for, if you've been here till now, I want to say thank you very much. Just keep like this video, subscribe to the channel. We'll keep updating you on better videos. Thank you very much.